What this is page 21 and 22. So the first problem is definitely a very just basic information that we have learned how to do. So that's where I expect your definite 1 point to come from. So this problem was about a organization or automobile manufacturer misleading customers and overstating fuel efficiency, and so they for a particular car model. So the first part, A, says define the parameter of interest. So that would be this first thing where you use mu equals, and you have to say average in miles per gallon, you need context, of this particular car model. In the grading guidelines, they really wanted to make sure you emphasized population. I think this would have gotten full credit, but a better answer would have been for all such cars of this particular car model. An even better answer. That would have been just like no question, you totally nailed it. All right, then the null hypothesis and alternative hypothesis. Null is just like this. I do not think that you would have lost credit if you did not put MPG, because you would have defined MPG in the parameter above. So as long as that was there in the parameter above, you were still fine. Okay? All right, as far as how it really actually looked on the grading guidelines, this is a condensed version. It's kind of a smaller type and hard to see a little bit, but I'll read it to you. This says, so the actual guidelines they used is that it is essentially correct if the student correctly states the hypothesis with a lower-tailed alternative, so the alternative was a less than, and correctly defines the parameter of interest by referring to the mean of the population, okay, and has it in context. For example, population mean, miles per gallon, true average fuel efficiency, average miles per gallons of all cars of this model, and such. Okay? All right, so you get partial credit, which is a half of a point, if you just have one or the other of those items. Okay, so hopefully you got an essentially correct on that one, because that's the one you definitely need your minimum 1 point from. All right, now let's go and talk about this. So this problem says they took a sample of 10. What does it say to you when you see a sample of 10? You're thinking what? That's not large enough, because for means we know we want to have at least 30. Okay, so this is a sample of 10. Now this one little sample that they took, they graphed to see what their one little sample looked like. And whether you had the box plot or the histogram, it was definitely skewed to the right. So their little data was skewed to the right. So then I see this stuff here. At this point, one way that they measured skewness was they did this ratio of mean divided by the median. The sample mean divided by the sample median. So at that point, when I read that, my brain is thinking of the stuff we've recently talked about, how mean and median and skewness, there's a connection there. And so we've recently referenced that. And here's what we said. The mean and the median, and if you are tail to the right, then you are skewed right. The mean is a bigger number than the median. Okay. So this made me know to think, ooh, I should probably be thinking about the mean and the median and the skew. All right. So based on that, this fraction is saying that the mean is the bigger number and that the median is the smaller number. So what would the value of this fraction be if the bigger number is on top? Greater than 1. So this is going to be a number bigger than 1 because the bigger number's on top, which leads into the question of part B. It says, what values of the statistic, and they give you a hint. Small, large, close to 1, okay? So that's your hint. Might indicate that the population distribution of miles per gallon is skewed to the right. So I'm thinking this is bigger than this, So it's going to be greater than 1. Here is the 2 things you had to include to get full credit for this problem. The first thing is you had to say that it is large values or values that are greater than 1. So saying that they are large values or values greater than 1 gets you partial credit. The other thing you had to include to get full credit is you had to reference the relationship between mean and median and say that this is occurring because when the mean is greater than the median, it's skewed right. Okay? So that gets you the other one. So at this point, look at what you've written and decide if you should get no credit or partial credit or full credit. Okay? I do want to ask you one question. What is happening when the mean equals the median? What is that saying about the shape when the mean equals the median? It is not uniform. It is, although uniform are symmetric, but symmetry. When the mean is equaling the median, we know we have symmetry because those are at the same location in the distribution. Yes? Yeah, uniform is like a subcategory of the symmetrical ones, but they don't have to be uniform. They can be other things like this. As long as they're symmetric, then there's that. You know, the uniform is also symmetric, okay? Or whatever, you know, I can't draw. Okay? All right. So you see, it doesn't have to be quite uniform as long as it's symmetric. Okay, now let's look at how that grades, because there's one interesting thing that they say that will knock you down to partial credit that I wanted to talk to you about. So they said, you know, you had to get essentially correct. You had to state that it was large or values greater than 1 and justified the answer of how right skewness and the relationship between the mean and the median, namely that the mean is greater than the median. Okay, but here is a way that you could have gotten partial credit, or could have not gotten knocked off for this little guy right here. This little guy right here had to reference mean being greater than the median. If all you talked about was you said it needs to be large values because if the mean equals the median, then it's symmetric. Okay, well, then, I mean, that's no-go. I mean, how do you connect it needs to be a large number because if the mean equals the median, it's symmetric? That basically gave you no credit for the relationship between mean and median because I mean, symmetry is one thing, but I need to know that this is the reason that they need to be larger than 1. Okay. All right, so give yourself your points on that. Now, this next one is the one that I went the wrong direction on whenever I was doing this problem. So let's kind of discuss and make sure we understand what the problem's referencing. So here we go. Part C says, even though the miles per gallon's value in that one sample were skewed to the right, is it still possible that the population is normally distributed? So it's saying just because you got one sample that was skewed, does that mean the whole population is skewed? What do you think about that? Just because you got one little sample that is skewed, and it's only 10 items, does that mean the whole population is skewed? No, because that, see, and it says, or is that skewness due to sampling variability? Possible, you know, okay, possible. So to investigate this, they took 100 samples, each of size 10. So all of these samples down here, each have a size of 10. Do not think N has now increased to 100, and then that automatically implies it's normally distributed because it's large enough. That's not what it's saying. This is 100 samples. All of them are still small sample sizes, okay? And they took these and they took each of these samples of 10 and did the mean divided by the median to see what value they got. Of course, if you got mean divided by median is 1, then that means the mean equals the median. So these ones right here was a perfect symmetrical sample. This one right here, this guy, that sample right there had a perfect symmetrical sample because its mean equaled the median. Okay, what can you tell me about all of these samples over here that have one of those statistics that's bigger than 1? Yeah, all of these samples over here, which there were 41 of them, because I had counted that, and that's a wrong, we don't need to know that information, but all of these ones over here were rat-skewed samples. Okay, all of these ones over here on the left were statistics smaller than 1, so they were left-skewed samples, of which there were 15 of them. So, question, just because you get some of these samples over here and over here, does that necessarily mean that the population is not normal? Okay, because these could be happening because of sampling variability. We don't know. Basically, we want to know how unusual is rare. I mean, like, are these rare enough over here on the outside edges that we call into question the shape of normal? And that's what the question asks next. The original one on the previous page, the original sample of 10 on the previous page had a statistic of 1.03, right? That's bigger than 1. And the one on the previous page was skewed right. So here's the one on the previous page that was skewed right. Its statistic is 1.03. So based on that, is it plausible that this original sample of 10, this guy right here, is coming from a normal population and it's just due to sampling variability? Or does this sample result, and these sample results suggest that the population is really skewed to the right? So, so the idea is, if our null hypothesis says that the mean is, that this statistic, the average of this statistic is 1. If that's the case, if the average is 1, then we have got a normal model. But if I reject this and I say the average isn't 1, then, then I would reject this and say the population isn't normally distributed. So what do we need to know about our little sample to see if we should if 1 is plausible or not plausible? What should we do? Okay, not mean, but how do we reject or fail to reject in a hypothesis test? P-value. So in a sense, I need to find this one's p-value to see if it's unusual. Is this sample far enough away to call into question mu equaling 1? That's what I want to know. Is this an unusual sample to call into question this guy right here? So, with that, what we're going to do then is talk about its p-value. What is a p-value? P-value is the probability of getting this sample something more extreme if the null is true. So based on that, there are 14 items at this sample or higher. So essentially, according to my little sample here, my sample has a p-value of what? 0.14, because it's 14 out of 100. Boom. And what do we say with a p-value of 0.14? Do we have evidence to reject this null hypothesis? No. So this sample is not unusual enough to reject the null hypothesis because it's p-value of 0.14. So that is where we go with that. First of all, okay, so let me tell you what I wrote, and then I'm going to tell you, I even think with what I wrote, I probably would have still only gotten partial credit, so we'll fix it. But what I wrote was this. There are 14 items bigger than 1.03. So 1.03 is not statistically significant. It's not unusual. It's not, you know how you said alpha was the 0.05? It's not in the top 5% of the data. It's not in the rejection region. Okay, all those things. Therefore, 1.03 could happen because of sampling variability if the mean is really 1. So, even with this statement, I suspect that I still would have not gotten full credit yet because I didn't actually answer the question. The question is it plausible that the population is normal? So I'm pretty much I need to say yes or no first. So is it plausible that the normal model, that the population could be normal? Yes. So dadgummit, don't forget to answer the question and then explain. Okay? So even me, teacher, and I've done this years after years, just today went, I never really answered the question. Okay? So there you go. So that is a full response. Okay? By the way that they described it having to get full credit, they said this. Part C is essentially correct if the student states that it is plausible. That's what I boo-booed on and I didn't do. That the sample came from a normal population and justifies the choice with specific numerical evidence such as a p-value, such as 14% of the values are above 1.03. Okay. Now, the interesting thing is, I want to show you how you would have gotten partial if all you did was reference. It says you would have gotten partial if you state it is plausible, but look, if all you did was said 1.03 is within 2 standard deviations of the mean. Isn't that interesting? I know, but one of the things I was wondering is, do we know what the standard deviation is? See, how do you know it's within 2 standard deviations? So that was one thing I was wondering about. How do you know it's within 2 standard deviations? But can you reject or fail to reject a hypothesis test with a z-score? No, it has to be a what? P-value. So that's why this is a no-go. Okay? You don't have statistical evidence with a z-score. You have to have it with a p-value. Yes, ma'am. Well, they said because I had because I said there were because I said this. That kind of references that p-value. Okay? All right. Very good. So the original way, look at the original. I was going way off when I originally did this. I just counted, oh, there's 41 up here and there's 59 down here, and I'm like, well, if anything, that references that they're skewed left because there's more of them over that side. But I should have not even gone that way. Is that how you do a test, just looking at what's on either side of the mean? No. But anyway, so I originally totally got 0 on that question. Now, part D says, the table below shows summary statistics for miles per gallon, and so there's some data. Choose, basically I wanted you to define another formula other than the one that they did to show that there's skewness. So what I want to discuss with you is a box plot. You know, we got this going on here. Okay, so there's our min, our Q1, our median, our Q3, and our max. And my first question is, what would this box plot look like if it was skewed to the right? What are some ways it could look if it was skewed right? Median to the what? Okay, very good. If, say, the median to the Q3 is really huge as compared to the median to the Q1, that would look skewed right. Okay? And then you know, whatever these are doing, that doesn't matter. Okay? So in this case, let's talk about that formula. I would be saying that this Q3 minus the median is much bigger than, is the bigger number than what? Median minus Q1. So I'm saying Q3 minus median. This distance here is bigger than this distance here. So that's greater than 1. So there's a formula. I think when I originally did this, I wondered if I could put this, because is this considered a formula if I say Q3 minus median is greater than median minus Q1? Yeah, it's the same thing, but I wonder if I could have left it in that format and gotten credit. Or if I had to do it in a ratio. Ooh, let's look at the directions. Did it tell me to do a ratio? It just said define a formula. Oh, see, look, that's kind of why I originally did that. Anyway, I would have to be an AP grader to know if they accepted you leaving it in that format there. Okay, what's another way a box plot might look skewed to the right? Big whisker, right? That big max and big whisker. So here's another way it could look skewed right. Maybe this is, regular or something, but you got this going on. Okay? So there's a couple ways you could do this. What is the big difference? Max minus what? Q3. Okay, so that's saying this guy is much bigger than, what is this? Q1 minus min. Okay, I think you could also do another one on this. And actually, I did another version of this. What's the other version of this you could do? Max minus what? Median, yeah. The distance from the max to the median and the distance from the median to the min. Okay, that could work as well. So those are all different mathematical ways that you could also decide if it's skewed right. So that's what they were looking for. Here's the way it looked on the grading guidelines. They gave lots of options. So the AP graders had to look at all these, different formulas that you could do and even see if you had something different that worked. Okay, you got full credit if you got it completely right. You got partial credit if you got the formula right, but say maybe you flipped it upside down and you had the small number on top, okay, and the big number on the bottom or something like that. So I want to know how you did full credit or, points. So let's tally your points and let's see how you did on this problem. Raise your hand if you got at least 1 point. Okay, good. Raise your hand if you got at least 1.5. At least 1.5. Okay, if you got 1.5, then the AP grader at that point decides how the rest of your problem is, and if you were kind of on the right track with stuff, then they might decide to bump that 1.5 up to 2. It's their decision to bump it up to a 2 or to bump it to a 1. So you would need to kind of look at the rest of your things and think if you're on the right track and you should deserve 2 or 1. So how many of you 1.5ers think you should go up to 2? How many of you 1.5ers think you should go up to 2? So how many people do you think got 2 or higher? 2 points or higher? Okay, so we're at 3. Okay, so that's good. I mean, you people who got 2 points or higher, that's good. You're above the national average. The national average is 1.8. Okay, anybody, what else? What did you get? I got 2. 2. Okay, what did you get? 2. Jacob, did you say you got? Okay, so there we go. All right, so 2 is super solid. 1 is, phew, at least you got something. So let's start seeing if we can do better on these problems so that we can get a 2. That's our ultimate goal, okay? Ultimately.